First off, I have to tell you that according to the publisher, this textbook is now in the shops. They sent me an email this week. I haven't verified that, so I haven't been to the two shops they mentioned, but you should be able to find it. I was a little taken aback because I thought the first chapter would still be fine online, but I didn't realize that I've actually mixed things up a little bit by talking about functions. So that's not in the first chapter, and you'll either need the book or need to mug and kill someone who has the book and take their book. Okay. Right. I've stolen this book from Anthony, that's right. So, because I want to show you something inside the book. Now, I was supposed to tell you about the project on Tuesday, but other things came up. So then I kind of told you about the project yesterday, but it didn't work out too well because this laptop wouldn't work in Nargadi for some new reason. So I'm just going to do a little bit of what I did yesterday. If you were there, I know it's a little boring. We'll try to make it quick. And then we have to talk a little more about libraries and what you'll need for the second part of the project. So I'm not going to talk about the project itself. I will again next Tuesday in the second TAT at least answer questions. But what I wanted to show you was our progress with tic-tac-toe. The best thing about this room is because of the high resolution, I can actually show the full website without having to squeeze the screen in any way. So, all the stuff is here. There's just one tiny piece that's missing. And that is that even though, and if you're in the Tuesday TAT group, I know this is all news to you, but even though I did give you this outline, still want to make it bigger, but not like that. Let's just go back. Let's do that. So even though you have this outline that we talked about yesterday, and you should be writing those first 4 files, and then for the final project submission, add the 5th. And even though I've given you this stuff, there's a link to networking, but that's fine because no one expects you to write that. Standard draw you need because it's different from the one that comes with the book. Oh, what the? Oh, hang on. I clicked instead of just pointing. But board is different because board is a kind of framework for what I think should be in your board. But it's missing one tiny little piece. If you've rushed home yesterday afternoon to write the project and finish it up, you'll know that right at the end of board, there is a call, if I can find it. I can find it. To, what's misspelled? Initializing. No, it's spelled correctly.
It's the American way. Yes.
It is not the American way. It is the Greek way. In English, there are 2 ways of spelling these I's words with an S or a Z, and it's not a difference between American and British English. It's a difference between using a Greek root and a Latin root. But we shall not talk about that anymore because I know virtually nothing. Okay, right. I wanted to show you that right at the end, it actually calls a routine is connected that I wanted to ask you to write, but on reflection, I'll give to you. So I'll still put up the code for util is connected. If you can write it yourself, that's beautiful, but at this point, it's beyond your capabilities. Maybe even beyond mine, but who knows? Let's see. Okie dokie. But what I really want to talk about, and what we did talk about yesterday, is our tic-tac-toe game, because that was incomplete. You'll recall that yesterday, we were still, yesterday being Monday, we were still looking at tic-tac-toe, and I was having trouble getting my laptop to keep up with the my typing. So it was still incomplete like that. But I'll fill in what I wanted to type on Monday. RC. Oh. Okay, right. So that's where we were on Monday. Now, honestly, quickly, just a few things. Firstly, This is tic-tac-toe. We have our little 3x3 board inside a class, a library that we've written called board. And I can call routines like init board and make move. Display board used to be in that board class. It used to be a function that we defined inside the board class library. But on reflection, because sometimes we want to display it graphically and sometimes textually, it's not a good idea to put it inside board. Unless we write two functions, one called board display textually, display graphically. But then we're tying board to a graphics library, or maybe even some kind of text display library. And I don't want to do that. I want board to be as independent as possible. A good library, or a good function even, does one thing and it does it well. The function of board is to represent the board and its operations. And it should be independent of anything else that changes. In 1,000 years, when people are using this software, they're not going to have graphical displays, they'll have holograms. And what is board going to do then? Well, be useless. I want my software to be able to run then, so I'm not going to put display board inside board. I'm going to keep it here, and I've already started writing it. And display board is trivial. It has two for loops. I just go over the rows and over the columns inside each row, and then I display the row inside the inner for loop, and I do a print line, so I can go to the next line. And inside the inner for loop, it's just an if statement that says, in fact, I'm going to change it from yesterday. I'm going to say int m, which will be marker, is board.get the marker at row R, column C. And if m is 0, I should display a dot. If m is 1, I display an X. And if m is 2, I'll display a big O. So now I'm calling this third operation get marker. So let's look at board. Board.java. It has the array where it actually stores the board. It has init board, that's already written. Make move we haven't written, and we should be writing it, but maybe not today. And now I want to add int get marker. Int row, int column. Get marker is called by my clients, the clients of this library, to find the marker at that position, and it's just going to send back what it knows the marker is. I store my board inside board. So get marker is a function that sends back an int, and it's simply going to send back board RC. That's all it does. Okay, so at this point I'm happy, but I'm a little concerned with all this calling of functions. Why couldn't tic-tac-toe, the library, simply have written board.board RC? What's wrong with that? Well, technically there's nothing wrong. Java will compile this. Okay, right. Now this is a challenge. It says scene 1, scene 2, scene 3, and scene 4. I think we're shooting a movie. Okay, let's see what scene 1 is. I like it. Oh no! Where's the little button for the lamp? Just give me a sec. Okay, how hard can... Oh, no. Okay. Good. Okay, that's scene 2. It's a little more intimate. I think it's a little... I like scene 4. Okay, good. I'll do this. As I was saying, there's nothing wrong with this. Java will compile it because board is a library and it has a board array, and I can access it by just writing .board, just like I can access any of its functions. But I don't want this, because tomorrow I'm going to change my mind about how I represent the board inside the board class. So, or I can change the name, as I did in the TUT. I may decide to change this board to a different word. Horde. I'm writing the board class or library, library, so I can change it in whatever way I want. It's my code. But if I do this, all the clients, all the people I've sent it to, their code will break. Because I've now changed something internal, but that they used. So it's a bad idea for people to use board like this from outside. These functions that I've defined, they are the interface to my library. They are protecting my library from outsiders. Outsiders can use the functions, and I make a promise, I make a contract, that these functions will always be available, and they will deliver what they say they are delivering. So get marker will always send back the marker in row R and column C. But I'm not telling you anything about how I'm doing that, how I'm implementing board inside here. I may not have a board array. I may have a hoard array. Or I may not have an array at all. I have many different ways of representing the board. So, how do I stop people? How do I protect my clients from abusing my board library? And one thing I can do is to change this public to private. I'm telling Java that the board or hoard array is something that is private only to this board library. No one else can use it. And in fact, I can make anything private that I want. I can make getMarker private as well. I can still call it inside this library or class, but nobody from outside can see it or use it. They cannot rely on getMarker to be available. But that's not what I want to do. So I'll change that back to public, but I'll keep hoard private. So let's see what happens if I try to compile tic-tac-toe. How do I do this? All this resolution and still can't find a nice, I know what I'll do. Make this one a little small. So, cool. Right, Java C tic-tac-toe .java. Ooh, it's complaining it can't find the symbol board. Yes, of course not. I changed it to hoard. So I'll change it to hoard. Let's try again. Compile tic-tac-toe. Now it's complaining that private hoard has private access in board. So this is an error. I cannot access it. It's telling me that. So I'll have to abandon this whole idea and switch to board. Get marker, which is the routine as the board library provides for me to access the board. Okay, now it's also complaining about other stuff. Okay, my mistake, I made an implementation mistake in here. That should be row and column. It's exactly what this error message is telling me. Col, okay, col. We all make mistakes. No, thanks. You must tell me when I make a mistake. But only when I want you to. Okay. Don't tell me when I'm actually posing an intriguing puzzle or enigma to the class. Fine. Okay, so now tic-tac-toe compiles and everybody's happy. Gotta speed up. One more thing. Maybe I want to play tic-tac-toe on a bigger scale than just 3 by 3. Let's want to make it 4 by 4 or 5 by 5, who knows. So instead of saying 3 all the time, I'm going to change it. I'm going to change it to a variable like that I set to 3 initially. And everywhere I use 3, I'm going to substitute board size. Okay. Everybody happy about that? Will it compile? Yes, actually it will compile, but there's a mistake in my code. I can sense the presence of a mistake, a disturbance in the force. I'm still using 3 inside tic-tac-toe. But I don't know that the board is 3 by 3. So I should really change this to board.board size. Okay, now we're all happy because tic-tac-toe looks at board size. Did I do? Yes, I did it correctly. To know the size of the board. But something can go wrong, and I promise you, if you have programmed, you have come across this, and if you are learning to program, you will make this mistake. Somewhere, you change something that you didn't think would be an issue, but now it turns out that it actually is an issue because it affects other parts of your code, remote parts. And the way that making a change here can affect something right on the other side of your whole code base is that they're actually using a shared variable somewhere. In this case, display board is using board size. So let's crash the program. I change board size down here. I can write to it because I can see it. I can access it. It's a variable inside the board library, but it's public. So everybody can just come along and change it. Okay, let's see how I crash the program. Let's execute tic-tac-toe. Don't know if you remember, but it's supposed to print 2 boards. I have a make move call inside there, but it doesn't do anything. So it's just going to display 2 3x3 boards. Board size is still 3. Okay, everybody's happy. Oh, not Java. It's complaining about an array index out of bounds. When I try to display my board the second time. And that's because I changed board size in here, down here, and then when I call display board, it tried to display a 10x10 board, but the array is still only 3x3. So what went wrong? I mean, I can hack this. I can hack this to work. But what went wrong? Conceptually, what we is that I made this assignment. It doesn't make any sense. Making this assignment violated the way that board is supposed to work. The board library is supposed to take care of the size of the board and the contents of the board and all the operations on the board. I shouldn't be changing board size here. So what can I do? Well, just like the board array itself, I have a couple of options. I can make this private. Now it won't compile because I'm trying to access board size from outside. And I could say, okay, right, if you want to access it, I'll give you a routine that you can use. Get board size. Doesn't take any arguments, but it'll send back the board size. That's one option. So board size is private, nobody can see it, the variable declared right at the top. But there's a new function that outsiders can call called get board size, and that'll give them a board size. But this is not usually what we do. We don't usually do it this way because board size is a constant. It's never going to change, we think. Let's assume. If board size were to fluctuate all the time, that's a different story. Then a function like this may actually make sense. Get current board size. But since board size is fixed forever, what we usually do in these situations is to not write a function and to make board size public. But I want to prevent people from changing it. So I add a value, a constant, a keyword, a modifier to board size called final. And this final, with final I'm telling Java that this integer is getting its final value and it will never change again. Don't allow it to change. It's public, other people can read it and they can even try to write it, but it's final, it should not be changed. Let's see what happens now. Line 26, error, cannot assign a value to a final variable board size. So that assignment will no longer work. I'll have to take it out. And if I wanted to, I can still change the board size to 4. Everything will work. And it'll display the board just as I want it to, 4x4 boards. Okay. So that's what we did, roughly relating to functions in yesterday's stat. I don't think much else happened. Who was it at that? Come on, don't be shy. How did it go? Easy peasy? Rivaldo? Not easy peasy. Rivaldo? I know your name. Don't look out. Who's that guy, Rivaldo? All right, man.
I didn't mostly understand some of the things, but when I went over it again, it didn't make sense.
What a great advert. I'll pay you 10 rand later, okay? I didn't understand while I was doing it, but when I went home, I revised it, and it turned out it's easy. That's what he said, isn't it? Laughing all night. It was so easy. What? And you cooperated with your fellow students. That's beautiful. It's not a bad idea to collaborate. But when it comes to the project, we are going to run it through plagiarism checkers. And the rule is very easy. You must get all the help you want and ask for as much help as possible. But when somebody is helping you, don't go near the computer. Sit at a table and work on paper. And then, once someone is done helping you, you must be able to walk away and write the code yourself. I mean, that's a test if you really understand what they were saying. Do not sit in front of the computer. It doesn't matter. Eventually, your code will end up looking very similar to his or her code, your champion's code. So, Rivaldo, when you get help, don't go near the computer. Okay, right. So sometimes you have a bug in your code, you simply can't find it, and you ask someone to help you find it. And as long as they don't help you to fix it, it's fine. But if they kind of just help you see what's going wrong, that's fine. If you want to risk it like that, that's fine. I don't have to pass this course. I'm fine. Okay. That's called passive aggressive. It's not fine. Okay, never mind. Okay, fine. I want to show you more about libraries and what you're going to do in the second semester, and especially since we're not going to come back to this at all. So, let's assume that you have a copy of the textbook, and you don't even need the actual textbook because it's in the part, I think, that we're going to study. So today we're going to quickly, what? You can't, oh yeah, no. As long as I can see, it's fine. Today, just give me a second. I just need to find it. Okay, maybe I'm mistaken. Oh, okay, 147. So this is still an electronic copy. I know you can't see anything, blah, 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 yes, sad story, yes, all that. Okay, right. So, you've already read this, but there is this chapter called 1.5. I'm sure you've read it. Okay, I just need to zoom out. Can I zoom? Oh yeah, I can zoom here. Zoom in. Oh, I don't need to zoom. Okay, all I need to do is to find the right position for this thing not to... Is that better? No. Okay. Hang on. Yeah, I'll have to, won't I? No, that's not good enough. Okay, I'm going to switch to scene 1. And lamp. Okay, maybe I'll see scene 2. Scene 1. No, it's fine. It's fine. It's okay. I'll just. Oh, this isn't fine at all. This is not scene 1. I've not seen 1 anywhere. Okay, that's exactly what I want. So this chapter called Input and Output. It's all about 3 or 4 libraries that are distributed with the book. We don't use them this year because I feel they kind of get in the way. But the idea of the authors was that if you have these simplified libraries, it'll be easier for you to start writing programs. But we just jumped in and used system out at print line right from the start, and then eventually we learned about scanner a couple of weeks ago. But these guys have libraries to make input and output easier. And they're called standard std out and standard in. And maybe eventually they will make life easier. But you must have already seen these libraries. Okay, so this is standard out. There we go. And they give you us a little summary like this. Oh, I like this. Hang on. Oh, wow, that's big. A little too big. Okay, fine. It's not going to fall. Right. So this is a little way of presenting us with the API, the contract, the interface that we can use to access public standard out. That's a library they have. And we can call those 4 routines: print, println, println, and printf. And they all are void functions. So they're not send back a value, and they take those parameters. Print takes a string, println takes a string. There is another version of println with no arguments, so I can call it like that, as we have been calling system out println until now. And there's even a printf that takes many strings, many values. Okay, so that's standard out. Standard in is roughly equivalent to our scanner, but it's a little bigger. Let's do it. Okay. Fit it all. So let's just quickly read through it, see what it gives us. Can we do this stuff? Is empty. Are there more values coming, or is it the end of the values? We haven't really been doing that. It's a little odd. Read int, we can do that. Read a double, read a boolean, read a string. We can do all of that. Has next char and read the next char. Well, we kind of did that in one of the tuts. Read the whole next line. We can do that. Read all ints. And send back an integer array. Well, we can't do that. We haven't known how to do that. Read all doubles. So this reads a whole array from the standard input. Not from the command line, where the arguments are. We access those with args 0, args 1, args 2. But these routines will read like we are reading by making a scanner and saying scanner.nextInt. This will read a whole lot of ints until there are no more and put them all in an array and send back the array to us. That could be really useful. But we can write our own version of that. That's fine. We don't need that. Okay? And then there's also something called read all, which it just reads everything it can and then sends all of it back at once. Okay, so this stuff looks interesting, but we don't really need it. We have all of that. Is that just my psych medication that's phasing out, or is some dentist working up? That's horrible. Okay. What do you want? Folk, what? Can't hear anything, yes. I didn't say I was hearing something. Okay, fine. Good. And this stuff we can write ourselves. Okay, so that's fine. Standard in, we don't need it. Chuck it. Don't care. Oh, look, this is such interesting stuff. I wish I was a first year again. Look, 20 questions. Oh, guessing game. Oh, cool. Averaging numbers. It's beautiful stuff. But what we really want to get to is this little beauty called standard drawing. Because for the second part of the project, and even just for fun, we want to draw stuff. We want to draw loads of stuff. So here it says, with standard draw, you can draw a line or a point. It sounds particularly boring. What do I have to do this? Okay, not much. Here is some more of it. There's also something called set canvas size, which will tell it how big the window should be on screen. And set X scale, set Y scale, and pen radius. Oh, I love drawing stuff. This is just drawing a line, and it uses that X and Y scale. Oh, and this looks fascinating. It's drawing a whole of America. Little dots. Actually, I think it draws cities or towns. Where are you from? Boulder. Marco? What? Oh, yes. Is it close enough? Yeah. Okay, where is that? Right there. California, big earthquake mountain, Nevada, Colorado. And here, where's Keegan? What's his name? Justin? Not here. Well, he's from here, is he? I see. And if I'm right, Pitbull is from here. I see. And Sarah Palin? Oh, she's in Russia, because I think she's in Russia, you'll find. She can see Russia from her front porch. Fine. I kind of want to draw a little map like that, but I didn't prepare. This is a spontaneous lecture, so I should have prepared this, and I should have prepared the little audio file as well. That's the best fun. Okay, but we'll do that next time. Let's just do one program that uses a standard draw to see how we should be using it. I'll do this. I'll write plot filter. I can write that. Plot filter, Java. And I can also learn about how to use this stuff. So it says public class plot filter. Okay, let's do that. Quick. Let's steal code. Tic-tac-toe, where are you? Here we go. Plot filter. Fine, and it has just a main. Okay, what does it do? It says double x0 is standard in. Oh, see, I don't have standard in, so I'm going to replace that with the scanner. Scanner, SC, scanner, system.in. Is that the formula? Let's hope so. There we go. Okay, so now I'll have to say sc.next double. That's fine. And then I'm going to read y and x1 and y1. So that's easy peasy. Done. Then there's a while loop. It says while standard in is not empty. Oh, I don't know about this next, not is empty. But maybe I can find something that will, do I have internet access? Yes, I do. Let's see, Java API for scanner. Okay. So what kind of routines does it have? Here we go, method summary. Oh, I must admit, there's one thing I neglected because it's so natural and ingrained in me, but the functions we've been writing, sometimes people call them methods, and that's the technically correct name, because they're not always functions. When they don't send anything back, that's not exactly how a function behaves in mathematics. So really, we should be calling them methods. But there are many other names for them that I just use interchangeably. People call them procedures. So that's a list of all the procedures inside the scanner module. Sometimes people call them routines. So that's a list of all the routines I can call, or invoke, or execute. So there are a lot of terminology that I just assume you naturally picked up, but it's really bad teaching on my part. Just making this a little bigger. It's a summary of all the things I can do inside scanner. And I'm pretty sure I've been using some of this stuff. Next int scans the next token of the input as an int. Next double. But it also has these routines. Has, next, double. Returns true if the next token in this scanner's input can be interpreted as a double value. So I'll use that. I wonder if it has empty. Has next. Well, that's good enough. Any kind of next token. Yeah, let's use that. So let's go back to our, I'm still copying this code really, while not scanner, while scanner has a next token. Is that correct? Feels right. Read 2 more doubles called x and y, and plot the point. Standard draw dot point. That's one. Okay. And I see I missed out on these things. So what do they do? Well, set scale, x scale, which you'll know from reading the book, sets the minimum x value and the maximum x value I want to plot. So today I want to plot things from 0 to 1. So I say set x scale to 0, 1. And that tells standard draw that all the values will be between 0 and 1. So that's what it should be expecting. But tomorrow I want to plot values from 0 to 1,000 x values. If standard draw is still thinking that all my values will be from 0 to 1, it will only plot those values, and all the values outside from 1 to 1,000 won't be plotted. So I have to tell standard draw what values to expect. Standard draw dot set x scale x0, x1, same for y. This time it's the y scale. Okay. So this seems fine. Let's see what happens. Anybody have any issue about this? I don't think so. They didn't. Anybody has any issue? Okay, none. Okay, so let's compile and run this little program. I'm so excited. Oh no. Error. Cannot find symbol. Standard draw. Big surprise. Java doesn't know standard draw. So Justin was right. I'll have to import it, just like I did for scatter. So, but what do I say? What do you what? Sorry, I can't hear what you're saying, Rivaldo. Did I make a typo? It's very easy for me to make typos. Oh yeah, small s. But that's not the issue, I promise. Well, maybe it is. How do I know? It did point to standard draw as the error, its symbol it couldn't find. So I think it's still the same issue. So now I need to get a hold of standard draw. So I could go and download the copy of the books on the web. But I've already given you a copy of standard draw that is a little more powerful than their version, just because it has the mouse. So I'll just download our own version, which is right here. I'm going to save this. Okay. And I believe that, yes, the browser called it standard draw.txt, but I just want to call it Java. Okay, so now I've put standard draw inside this folder where I am, and I believe I can just use it. I know I can just use it. If I downloaded the official copy, I would have to do a little more work. So the official copy called standard, for the official version, and they'll said explicitly on their system. You have to write edu.princeton.intro.cs.standard. I think. You have to import it just like you imported Scanner. But this version that I have, you don't. Okay, now I need usa.txt. And I know for a fact that I have it somewhere. But it's too much trouble, so let's just go steal it on their website. Princeton Computer Science Sedgwick. Yes, seems right. It looks right. Data. And somewhere there should be USA. Ah, here we go. This doesn't feel right. Something's wrong. I can sense an issue. Fine, we'll take it. I don't like it. So first off, I'm going to make my own copy. Because I've got a feeling that these files are quite large. They have 13,000 points, and that's going to take a while to plot. So I just want to see if it works. And what I'll do is I'll just delete. I'll just want to draw those points. Okay, fine. Let's go. Java plot filter USA Yahoo. Okay, so what's going on here? I'm running my program, java.plotFilter, and it's going to read from the standard input. So ideally, it doesn't prompt, remember. So let's just make an example. It is now reading x0 and x1. Sorry, x0 and y0, so the smallest x coordinates. Let's say that's 0 and 0. And then it's reading x1 and y1, which are the biggest. And let's say that's 1 and 1. It set the scale. While there are still more doubles to come, it's going to read two pairs of coordinates, or a pair of coordinates, and plot the point. So I'm just going to plot a couple of points. I'm going to plot 0.5, 0.5. I have a null pointer exception. Instant site standard draw. And it was called from this place, and it was all called from plot filter in line 16. Line 16. Or maybe 17. Okay, so one significant difference that I just ignored is that when you use this standard draw, you have to initialize it, just like you initialized board. So before I do anything, I should really be saying .init. That'll initialize standard draw. So let's compile again. Okay, my mistake. Just give me a second. Oh, standard. Now I'll have to look at the code. This is a little odd, but I'll just change it to public. I must admit, I'm not sure what's going on. Well, that's the way it works. Okay, fine. Let's try again. I'm going to enter all those points. 0, 0, 1, 1, 0.5, 0.5, 0.5, 0.25, 0.25, 0.25, 0.05. Okay, and here it is plot all my points, as you can see. Can you see them? You can. No, that's just dust on my screen. It's clear? Okay. Okay, right. So, a couple of issues. I can't see those points. If there are too few, I can't see them. So, you need a lot of points before you make any impression. So, instead of typing it by hand, I wanted to read all of those points from a file. How do I get a file into this program? I use this notation that's a part of Unix that say, pipe this file, I'll just use a big one, into this command. The command is Java plot filter. It'll take the file and treat that as a standard input for this command. So I'm going to execute that. It's taking its time. Oh, here we go. But I can't see anything. Yeah, but that file has been prepared, so that actually I think it's already correct. But I can see a few points. Can I? Say again? Set the scale. I did set the scale. Where? In my program. That's where. Okay, let's just fix this. Let's see if I can fix it quickly. So, let's find out if the minimum is really set at the start, as I promised. This file starts with 24. That's supposed to be the minimum. But is it really? I think so. And that's supposed to be the Y minimum, but I can see for a fact that it's not. So I'll just have to quickly JPO this. Let's see. Copy USA 135 to txt. This is going to take me a second, I promise. u.txt, okay. Cut out this part. Okay. Sort USA 13 head -1. So that's the minimum value. That's the maximum value. That's the maximum Y value, and that's the minimum Y value. So I need all of this stuff. Okay, that's minimum X, maximum X, minimum Y goes there, maximum Y goes there. There we go. Run again. It's not going as smoothly as I'd hoped. Oh no, it is. And then the beautiful United States is traditionally represented in the shape of an eagle. Something's wrong. I just don't know what it is. Can't trust this. I can fix it easily. What is wrong? it's rotated by 90 degrees. Okay? So it's treating y coordinates as x coordinates and x coordinates as y coordinates. So I kind of need to swap those around. Let's just see if we can quickly do it. We have 1 minute. Dum, dum. This is like Mission Impossible. Dum, 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 dum. Okay. Oh, no. No. Today we're going to fix it by fixing plot filter. When it's reading an y, so y, x, y, x. No, it's y, x. Compile, run. Seems right. It still seems a little odd. Something's wrong, but I put my finger on it. Seems California. This is my. Now, to Marco, this looks wrong, but of course to us it's correct, because when we looked at the United States, we looked through the Earth from the back, and this is the way around we see it. Okay. I have to stop, but I'll see you again either on Tuesday or next semester. Remember, we don't have class on Monday, Wednesday. All right. Thanks, guys.